The sun above you right now has been burning for 4.6 billion years. It will burn for approximately 5 billion more, and then it will kill everything. Not with an explosion, not with a supernova. Betelgeuse goes supernova. Our sun is not massive enough for that. Our sun does something slower, something that in many ways is stranger. It swallows us. Let's talk about exactly how that happens, and everything that occurs before it does. Right now, the sun fuses approximately 600 million tons of hydrogen into helium every single second. It has been doing this for 4.6 billion years. It will continue for approximately 5 billion more. At that point, the hydrogen in the core runs out. This is where things get complicated. When the hydrogen in the core is gone, the core contracts. It gets smaller and hotter. The heat from the contracting core causes the outer layers of the sun to expand, slowly at first, then faster. The sun begins to grow. Over hundreds of millions of years, the sun expands outward. Mercury is the first to go. Its orbit is consumed by the expanding solar surface, then Venus, the sun's surface reaching further and further outward through the inner solar system. Then Earth. Here is what actually happens to Earth long before the sun reaches it. In approximately 1 billion years, the sun will be roughly 10% more luminous than it is today. That does not sound like much, but 10% more solar energy is enough to push Earth past a critical threshold. The oceans begin to evaporate. Not gradually, catastrophically. As water vapor enters the atmosphere, it traps more heat through a runaway greenhouse effect. The more water evaporates, the hotter it gets. The hotter it gets, the more water evaporates. Within a geologically short period, perhaps a few 100 million years, Earth's oceans are gone. All of them. The surface temperature climbs past 100 degrees Celsius globally. The atmosphere becomes dense with water vapor and carbon dioxide. The rocks themselves begin to release CO2. Earth becomes something uncomfortably similar to Venus, a pressure-cooked world with a thick toxic atmosphere and a surface hot enough to melt lead. And the sun has not even started its red giant phase yet. The red giant phase begins in approximately 5 billion years. As the core contracts and heats, hydrogen fusion begins in a shell around the core, not just at the center. This shell burning produces enormous energy. The outer layers of the sun respond by expanding dramatically. Over roughly 1 billion years, the sun's radius grows from its current size to approximately 200 times larger. Its surface area increases by 40,000 times. The sun's outer surface cools as it expands, dropping from 5,500 degrees Celsius to approximately 3,000 degrees. This cooler surface temperature is why it appears red, hence the name, red giant. At its maximum extent, the sun's surface will reach approximately the current orbit of Earth, possibly slightly beyond. Earth, if it still exists as a recognizable object, will be inside the sun. What would the sky look like from Earth's surface in that moment? Not blue. The sky would be the surface of the sun, in every direction, above, beside, everywhere above the horizon, the roiling, churning plasma surface of a dying star, replacing everything we know as sky. The temperature at Earth's location would be thousands of degrees. No atmosphere, no water, no magnetic field, no anything. Just rock and the sun surrounding it completely. This is not a dramatic explosion. This is something quieter and in some ways more complete. The sun does not destroy Earth from a distance. It absorbs it, consumes it, pulls it inside itself. And then what happens to the sun? After the red giant phase, The sun does not explode. The outer layers drift away slowly, expanding outward into space as a glowing shell of gas called a planetary nebula. Beautiful, expanding, visible for thousands of light years. What remains at the center is a white dwarf, a compressed remnant roughly the size of Earth, containing the mass of the sun, cooling slowly over trillions of years. No more fusion, no more light, just a fading ember in the darkness. The same sun that has warmed every living thing that has ever existed on Earth, every species, every civilization, every moment of every human life, reduced to a cooling coal in the dark. Look up at it today. It is 4.6 billion years old, halfway through its life. And it has never looked more ordinary. The sun is dying, slowly, and everything that happens on the way is even stranger than the ending. If questions like this keep you up at night, subscribe. I answer a new what if question every single week, and the next one is even stranger than this.